Welcome back to the channel. In our previous video we have covered the machine learning lifecycle, which contains 10 steps. Those 10 steps were problem definition, data collection, data cleaning and preprocessing, exploratory data analysis, feature engineering and selection, model selection, model training, model evaluation and tuning, model deployment, model monitoring and maintenance. Today, we're diving into one of the most vital, yet often overlooked, pillars of data science and machine learning: data cleaning. You can build the most sophisticated neural network in the world, but if you feed it garbage, you're going to get garbage out. So, what exactly is data cleaning? It's the systematic process of preparing raw data by detecting, diagnosing, and correcting errors so it can be effectively used for downstream analysis. It is the foundational step in data preprocessing that ensures your datasets are clean, structured, and ready for statistical modeling. Raw data collected from real-world systems is almost always noisy, incomplete, and full of inconsistencies. Without cleaning, these flaws propagate straight into your models, degrading accuracy and producing unreliable predictions. Clean datasets are equally critical for exploratory data analysis, EDA. EDA relies on transparent, interpretable data so business stakeholders and engineers can extract accurate insights and take the right strategic actions. Throughout this video, we'll cover the fundamental techniques, from deduplication and outlier handling to structural fixes and imputation, giving you a complete blueprint to master the data cleaning workflow. Before we clean data, we need to understand how it gets dirty. Data quality issues usually stem from human entry errors, system pipeline failures, or bad integration during collection. Some of the most common data quality issues are missing values, duplicate records, incorrect data type, outliers and anomalies, inconsistent formats, spelling and typographical errors. Now let's understand them one by one. The first major anomaly is missing values. Incomplete records reduce your dataset's statistical power and can introduce dangerous bias into your models if certain groups or ranges are systematically missing. Next up, duplicate records. Repeated entries skew your distributions, making specific observations appear far more frequent than they actually are, leading to overrepresented outcomes. Third, we encounter incorrect data types. Storing numbers as text strings or dates as generic objects will crash downstream code, break mathematical operations, and stall automated pipelines. Then we have outliers and anomalies. Extreme high or low values, whether caused by measurement error or rare events, can distort statistical metrics like mean and standard deviation, pulling model weights out of alignment. Finally, inconsistent formats and typographical errors. Mismatched date standards, conflicting units, or simple spelling mistakes prevent algorithms from grouping identical categorical values together correctly. Data cleaning process contains several steps starting from assessing data quality, removing irrelevant data, fixing structural issues, handling missing values, normalizing the data, finally identifying and managing outliers. Now let's understand them one by one. Step 1. Assess data quality. Before changing anything, audit your dataset using profiling tools to check for null values, range boundary breaks, and structural irregularities. Identify whether missing values are random or systematic. Verify if age fields contain negative values or if price columns hold invalid symbols. A thorough audit prevents blind edits later on. Step 2. Remove irrelevant and duplicate data. Duplicate entries inflate sample sizes falsely. Use technique pairs like sorting, grouping, or cryptographic hashing to detect and purge exact and near duplicates. Simultaneously, drop redundant or irrelevant variables that don't add predictive power to your specific objective. Stripping away clutter optimizes compute memory and focuses your algorithm. Step 3. Fix structural errors. Inconsistent naming conventions and mismatched units cripple analytics. Standardize date representations across all files, trim trailing whitespaces, and unify casing across text fields. Ensure uniform scales across all measurements, for example, converting all distance values to kilometers or all financial metrics to a single currency standard. Step 4. Handle missing data. Missing values require strategic choices. Depending on the missingness mechanism, you can choose to infer, ignore, or drop these entries. For minor gaps, statistical imputation using mean, median, or mode works well. For complex datasets, apply advanced model-based techniques like k-nearest neighbors, regression imputation, or decision trees to estimate values accurately. Step 5. Normalize data. Organizing datasets reduces structural redundancy. Split complex flat tables into relational structures where appropriate to enforce consistent keys and streamline querying. Step 6. Identify and manage outliers. Deviant data points aren't always bad, but they must be managed. If an outlier is a proven measurement error, remove it. If the outlier represents a valid extreme event, apply mathematical transformations, like log scaling or Windsorization, to curb its extreme leverage on your machine learning algorithms. Having technical tools is one thing, but running an efficient data cleaning pipeline requires strategic planning. These strategic plannings are understanding of data, documenting everything, prioritizing issues, automate if possible, collaborate and communicate with domain experts, monitor and maintain. Now let's understand them one by one. Strategy point number 1. Understand your data. You must grasp the source, business logic, and domain context behind the numbers. Knowing business limits helps you distinguish between true extreme signals and systematic data collection bugs. Strategy 2. Document everything. Maintain clear logs of every rule, assumption, and modification applied. Reproducibility is crucial in production data science. Strategy 3. Prioritize critical issues. Not all errors carry equal weight. Focus your initial energy on high-impact anomalies that threaten systemic bias before spending hours on edge case formatting. Strategy 4. Automate and collaborate. Build automated cleaning scripts for routine ingestion pipelines. Collaborate closely with domain experts to validate that your cleaned outputs align with real-world business mechanics. Finally, monitor and maintain. Data quality isn't a one-time project, it's a continuous operational commitment to ensure long-term model reliability. Let's weigh the direct benefits against the trade-offs of rigorous data cleaning. On the advantages side, removing noise lets your model discover underlying patterns much faster, boosting accuracy and generalization while safeguarding user data privacy by purging sensitive information. However, there are real disadvantages to consider. Data cleaning is notoriously time-consuming, often eating up 60 to 80% of a data team's engineering hours. Furthermore, overly aggressive filtering risks removing real variance, stripping valuable signal and causing your model to underfit. To sum it up, data cleaning is the true engine of successful machine learning. Investing time in robust assessment, smart imputation, and continuous pipeline monitoring guarantees reliable insights. If you found this breakdown valuable, smash the like button and subscribe for more deep dives into machine learning engineering. Now let's check our knowledge with 25 multiple choice questions on data cleaning and preprocessing which we covered in this video.